I'm Philipp. I do too many conferences. I think this is the third conference in a row now. So I did one on Thursday in Munich, yesterday in Berlin, and today here in Kiev. And tomorrow I'll go home for 20 hours or so. And then it's the next conference. But yeah, it's conference season. It's good to be here. I have to talk in English because I speak very little Russian. I only learned a few bad words. So I cannot, maybe for entertainment later on. But otherwise, I will have to stick to English. So my talk is a bit about revolution and evolution. I always say kind of everything starts with the revolution. And for search, I don't know if you know that site dbengines.com. It's kind of like the TIOBE index. What that is for programming languages, that page is for databases or search engines or anything that stores data. And they have different categories, and if you look into the one about full-text search, you see this. This is the current state, and this was kind of the revolution. So you see Elasticsearch is kind of on top. They have kind of like randomly assigned points, but at 120 points, and Solar, the second one, would be at 70 points, whatever. You could see the development over time. It's logarithmic scale, so it looks very close, though it is not. So you can see kind of the development over the past few years, how the different products were developing and who was leading and who took over. And I always say this is kind of the revolution part. So generally, who uses Elasticsearch here? There's quite a few. Which versions are you on? Who is using 1 or earlier? Wow, okay. You have some catching up to do. I will only do stuff that happened in 5. Who is still on 2? 2, okay. Who? Okay. You have everything. Who is on 5? Okay, yeah. So most of the stuff I will show later on is for 5 or after 5 even, the upcoming 6 version. So why am I talking about that? I work for Elastic, the company behind Elasticsearch and the other products. I'm part of our infrastructure team, so I do stuff like Docker containers, AWS, Jenkins tests, though I try to stay away from Jenkins. Everything around automation, internal services, and I always say this is a Unix pipe. I kind of pipe that into developer advocacy, so now is conference season. Now I'm mostly out in the field to talk about all the new and nice stuff that we do. So how did it get started? Kind of how did the revolution got started? And Shai, our CEO by now, who started Elasticsearch kind of in his bedroom, he has this very nice blog post where he describes how he got started. And he says, like every good story, it started with a woman. And it was kind of it was his wife, because his wife was a chef. And she moved to London, and he came with her. And he didn't really find the right job right away, and he was kind of at home and didn't have much to do. And his wife had a lot of recipes, and he wanted to help her search the recipes to see, like, you have these 5 ingredients, what can you cook out of that? And that's how he got started with search. So it was kind of like just a hobby project. He wanted to help his wife. His wife said, like, well, I don't really care what you do, but it would be great if I could search my recipes. And he wasn't satisfied with what was out there in the search space, so he started creating his own search product. And the first one he created was called Compass 1, and then he did another one, Compass 2, which was a complete rewrite, and then he did another one, which was Compass 3, and it wasn't really called Compass 3, and 3 is obviously the lucky number, and he named that one Elasticsearch. So it's kind of the third iteration, but that one really got stuck with the community. At my previous job, my colleagues were already using Compass 2. Bad thing is, since it was a complete rewrite, you could not upgrade in any meaningful way, so you would always need to rebuild the entire thing. And so he got started with this. He did everything himself, starting from the logo to the website, to the documentation, to the code, to the issues. We always, at my previous company, said he is the he's the search beast because he was working so much, and we always felt like he was around the clock. He was producing new code and showing what to do and improving everything. Stuff changed a bit. This is still the output. If you kind of ping Elasticsearch and do a request, you can see I'm currently on 5.6.1. That was the one I was using for that, but the tagline we're using is still the same as in the very beginning. Elasticsearch, for search. It's kind of the search product. if you search any of these sites behind the search box, there is Elasticsearch. I guess I don't have to explain who they are. And we kind of built an entire ecosystem around that. So you might have seen there is Kibana for the visualization part, Logstash to ingest logs, that built the kind of infamous Elk stack. Who's using Elk for logs? Okay, that's quite a lot. That worked. It's widely used, like these companies, no point in going into the details. And then we added this one. This is Beats, the little fish. Written in Go, because Logstash was kind of nice but heavy. You always needed it was Ruby in the beginning and now JRuby, so you always needed the JVM, and people were not too fond to install the JVM on all the servers. So the Beats are kind of like the native thing to collect logs now. The problem was there is no bee in elk, and we had to come up with another animal. And at first we tried this. This is the belk, or the elk bee. And you can see it's a bee and it has elk horns. But we're always about scalability. And marketing then decided this is not very scalable, because what happens if we add another product and we add another letter? Then we need to make up another animal, and it's getting harder and harder to make new animals. So they kind of found the scalable way, and that is, we now just call it the Elastic Stack, because whatever open source product we have, we can just put it into that, and we don't always have to rename it. And yeah, renaming products is hard. Like, I know there is Java Enterprise Edition, which was J2EE 10 years ago, and some people still call it J2EE. So it approximately probably takes 10 years to get rid of an old name, and we don't want to fight that constantly. And then we unified everything into one version number, so everything is on version 5 now. And that was kind of the revolution. And now we're getting into the evolution. And I want to talk a bit more about the evolution today, like what has happened recently. The first thing you might notice if you run 5.0, that is, it's a minor change, but I find it very nice, is about strictness. And actually, you see the thing here which says demo, we can actually demo all of that. So I will start my Docker container in the background. It will take a short while to get up, and I can show you what it's doing actually while it's happening. So we say Docker compose up. And it's starting some stuff. While this is starting in the background, I can just show you what is going on. So I have one Elasticsearch node here. I have just called it Elasticsearch 1 in a specific Elasticsearch version. I'll show you the version in a moment. It's a container. I give it a dedicated cluster name. I give it some memory settings. I configure some other stuff. Doesn't really matter too much. And then I have kind of the same thing for another second node. And we have a third node. And at the end, we have Kibana to actually access what is kind of going on, so I can show you what this is doing. And let's see, this is hopefully coming up. This is all live, so let's see how it's going. Let's see, demos have a tendency to fail, but hopefully not today. Okay, changed from yellow to green. This looks actually good. So let's see. We can access this with Kibana, running on the local host 5601, and seems to be working. That looks good. I'll make this slightly larger. Is that readable for everybody? Good. And just to show you, what are we running here? We're running version 5.6.1. You see, for search, this is the default thing we have. We have hopefully 3 nodes, even though it's a bit hard to read. Yeah, so you can see we have 3 nodes, 3, 2, 1. One here is the master node. It's just a very small cluster. You can say, how are you doing? It's telling you, yes, status is green, so the cluster is doing fine now. Everything is in order. And the first thing we can try is we have this query, and we want to run this query against Elasticsearch. Can you already see the problem? No, because it's kind of hard to see. This was a change we added in 5. It's telling you, like, this didn't quite work because there is something wrong. Because this parameter, token sire or whatever, doesn't exist. And in previous versions, maybe you have experienced that, if there was a parameter we didn't know, we would just throw it away silently, and you wouldn't know what was going on. And it was very hard to debug, even for us. By now, it's actually, whenever we don't realize a parameter, or we don't know a parameter, or we don't know anything you have in the configuration file, we will throw an error. So for example, if you have something in the configuration file which is not valid because you have a typo or something changed or doesn't exist, the node will not even start up. Because even for us, it was very hard to debug those. Like you have a 300-line configuration file and you have, I don't know, misspelled one thing, and it's just silently ignored. And you will search for half an hour or more just to find that thing. But by now, we will tell you, like, hey, this is not working. And this is actually suggesting, like, did you mean tokenizer, maybe? Because of the Levenstein distance, they are very close to each other. It can even suggest you what you might have done. The other thing we have added, so this is the setting for parameters and configs. Like, these are passed strictly now. The other thing you might have seen are the Bootstrap checks. Did anybody run into Bootstrap checks? Nobody. That's interesting, because often people complain about the Bootstrap checks. So the Bootstrap checks are, we are ensuring whenever we start up a node, we are ensure that as soon as you can form a cluster, so you don't bind to localhost, but to an accessible interface that it can reach something else and could form a cluster, we will do some checks for you. Like, we will check how many file handles do you have open. If you have too few file handles, the process will not start up. Do you have made any good or bad memory settings? If you have settings that we know will not work well, we will not start up. If you're using a Java version which we don't support, like the upcoming or by now released Java 9, we are, at least early access versions, we don't start up on. Like, it's just stuff we know that is causing problems or might corrupt your data. We will not start up on that anymore, because we would rather fail early than kind of try to run and then have lots of problems afterwards. So we're kind of trying to get a bit more strict there. Often people are complaining about that, but if nobody does, then that's good. And we'll just make sure that your cluster is running in a more stable fashion. The next thing that might be hard is shard allocation. So maybe you're aware, maybe you're not. Like, we have an index. This is kind of the thing where we store data into it. And every index by default is kind of segmented into 5 shards. So it's just like 5 pieces. And these pieces can be spread up over different nodes. Part of the problem is that shard allocation, like where does one of these pieces go, is happening automatically in the background. The nice thing is you don't have to configure anything. The not so nice thing is it's kind of like a lot of magic, and it used to be very hard to debug. And this is actually very nice to demo. So I am creating, let's see, I don't have that index yet. That is good. I'm creating a new index, and I'm saying I want to have one single shard in that case, just to keep it simple. I'm not doing any replicas, so there are no additional copies. And I make a rule that these nodes should not hold that shard, which is basically all my nodes. So this data will not be allocated in that example. So I can just run that. It will tell me, yes, I've created that index. And then I try to insert a document, and nothing is happening, because the rules actually tell it none of the nodes here can store that data. And once you run that, now suddenly your cluster state has turned to red. Why has it turned to red? Because if you check that index that I've just tried to allocate, it's telling you the index, my allocation, that is the index name, is red because it cannot allocate that one shard you're trying to store. And I mean, this is a very trivial example, and you can tell why it cannot allocate it, because we have 3 nodes, and I have excluded all 3 of them. But if you have dozens or hundreds of indices, and you have more complex rules, and you could have like node names or tags on the nodes, it's sometimes not that obvious why a shard is not being allocated or where a shard is supposed to go. So now we have this new API. It's the Cluster Allocation Explain API, and this can actually tell you why your data cannot be allocated. And it tells you, well, cannot allocate because allocation is not permitted to any of the nodes. And it has then a list where it tells you, these are the rules I've tried to apply. Well, and all your nodes kind of disqualify that. So let's change that. Let's say I can allocate that index or that shard to all the nodes except for Elasticsearch 1. So that should work. Let's see. Yes, it has been allocated. It will tell you the node has now been started and allocated. That is good. Let's see, do we have some data here? Yes, we do. So now the index is green, and you have your one shard here. Let me index my document again. And now you can actually search it. So it is stored, now everything is working. And you can check out like which node holds the data, so you can see that index or that shard is on Elasticsearch 2. Let's stop that node. What will happen? Let's see. And that was Elasticsearch 2. What will happen if I try to read the data? Yeah, you won't get anything back because it knows that shard should live on that node. I've killed the node, it's not reachable anymore. It will actually tell me no shard available, it cannot route to that one. And if you show it again, well, as you've said, the index is now red because you cannot read the data. And the Explain API can also tell you now again, because there is no valid shard copy anymore. Like the one single node that did hold that data, we've stopped that explicitly. So now we can restart the node, and the data should obviously come back again. It might take like a few seconds or so until it joins the cluster again. Let's see. So right now, the Elasticsearch 2 node is not in the cluster yet. Let's see. Yeah, now it's back. You can reread the data. It's still there. Now it's working. And now I add a replica. Now I tell it like, okay, I want to have a second copy. So the primary copy was on shard 2. On which other node will the copy now go? 3. Because I've told it don't store it on 1. So the other alternative is 3. I can ask it, and it will actually tell me yes. So I don't want the primary, but the replica shard I've just created, and it will actually tell me yes. This has gone to the Elasticsearch 3 node. So it can tell you all of that information, like what is even going on in the background. And now I change the allocation again. Now I tell it, I don't want any of that data to go to either Elasticsearch 1 or Elasticsearch 2. If I run that query, what do you think? How many copies of the data will I have? Still 2, or will it be moved down to 1 copy? Yeah, so that is a bit unintuitive. Like if you just change the rule and the shard is allocated, it will not change it right now. So right now you see the primary shard, that is the P here, was on Elasticsearch 2, and that replica I've just created is still on Elasticsearch 3, even though this is kind of against my rules. But as long as nothing changes in the state, that is kept that way. But if I kill the, let's kill the 2 node again. If I kill the 2 node again, now it will tell me, okay, the 3 node now picked up the primary shard, and it's not allocated on the 2 node anymore, because, well, it cannot go to that node anymore. If I restart that node now, will it assign the shard again, or will it not assign the shard? No, now it won't assign the shard again. So let's see, the node needs to join my cluster back again. So Elasticsearch 2 is back up again. You can see 3 is now holding the primary shard, and the replica shard is unassigned because we don't have any rules matching that. And the Explain API could actually tell you it doesn't even attempt to create the shard because it doesn't fulfill the rules. But this is actually really telling you why it's allocating something where. And before that, it was kind of like a black art, like you would need to dive very deep down into the logs and probably even increase the logging of some parts to see why something is working like that. Okay, next up. Cross-cluster search. Anybody using cross or tribe nodes? Anybody needing more than one cluster? So one of the things right now we have is, or we'll also have in the future, a cluster can only be in one geographic region. Like on AWS, you could like use different availability zones, but all the nodes of one cluster should be or have to be in one specific region. Yes, you can do that, and just use kind of like further links, like a wide area network with hundreds of kilometers in between, but your cluster will probably be not very stable. Or it will be stable until you hit some higher latency, and then your cluster will die a terrible death. So generally, one cluster needs to be in one region. And we have some big customers who need clusters in different regions, and they still want to query across all of them. Like, if you are a gaming company and you have players all around the world, you probably want to store their data in a specific region, but you want still to query across all of them. And then we added something called Tribe Node. And Tribe Node was actually a very interesting feature because somebody said like they needed it, and then Shai, our CEO, was flying back from San Francisco to Amsterdam, where he was living, and he implemented that feature during that one 12-hour flight. And the colleagues said afterwards, well, it's working, but it shows that he only had that much time, because it was kind of the quickest implementation he could do. So basically what the tribe nodes do is you have two clusters, like the left and the right, those are two clusters, whatever, the sales cluster, the R&D cluster, or normally they would be geographic clusters. And that tribe node, that poor little tribe node in the middle here, that is joining every single node of every cluster. So assume you have 3 clusters, and each one of them have 20 nodes. So that tribe node would need to join to 60 other nodes. And by default, it's a peer-to-peer network, so every node opens 13 connections to every other node per direction. So that is 60 times 13, that's a lot of connections. And that tribe node also needs to kind of keep the cluster state of all the nodes and merge it together. So it was a very heavy operation. And the tribe nodes were, especially in very large clusters, if you combine lots of them, it was very heavy and not that fun. So that was re-implemented now properly into something called cross-cluster search. That is much more intelligent now. So that thing basically connects to one of the nodes in each cluster, delegates its queries to that node where you connect to will then run the query in that other cluster, collect the information, and hand that back to the cross-cluster search node. So it doesn't need to have all these connections open. The next major thing we have is going forward from 5 to 6 is a rolling upgrade. So you don't have to do a stop the world upgrade. Right now, if you were going from 1 to 2 or from 2 to 5, you basically had to stop the entire cluster, update all the nodes, and then bring them back up. And if you have, for some use cases like logging, this might be acceptable, where you just create an old cluster and a new cluster, and you write the log data to both for a month, and then you throw away the old one. But for some use cases, this was a major pain. Like if you have like an online search catalog, and it should be available all the time, that downtime, even if it was just 3 hours, was kind of unacceptable. And we have rolling upgrades now, where you can just add newer nodes to the older cluster. You will need to be on 5.6. That is the only version from which you can roll forward to 6, but within 5 you can do rolling upgrades. So you can just roll forward until all the nodes are on 5.6, and then you can start rolling those over to 6. And we can try to do that now. I will just insert some documents, we might need them later. So we have inserted that. The first thing we want to do is we need to change the version. I'm using a .env file, so basically I'm commenting out this one, and I'm changing. For 6, we don't have a stable release yet. We have a release candidate. I'll just switch over to that. It should already work. And what I'm doing now is I'm basically killing the Elasticsearch 3 node and replacing it with a new one. And it's recreating the Docker image. And you will see a lot of logs scrolling down here because the node has been dead and is now trying to join back. Let's see how our cluster is doing. Here I've added a few other parameters, like I want to see the IP, the ID, the version, if it's a master node, and the node name. So here you can see right now we have only 2 nodes, 5, 6, 1 both, but 3 should come back any minute now. Yes, it has come back, and you can see this is a mixed cluster now. This was not possible in previous versions where you had 5 and 6 mixed. This would not have been possible. So now we have replaced that one. You can still read data. It's fully operational. But we can now upgrade the rest of the cluster. So let's do the next one. Let's just do 2. I think 2 was the master node, if I remember correctly, so that might take a little longer. Oh no, 1 is the master node. So 2 should also be pretty quick. It will come up any second now. The one thing you might think previously updates were hard, and now updates are easy, and you will just always do rolling upgrades. But our recommendation is generally, if you can, still do a stop the world upgrade, because it's much easier. If you do this rolling upgrade, you need to do much more testing, like as much testing as you can do. Because there are many more error scenarios, like it's just more error prone. Be very careful with that. You can just roll forward, but don't assume it will just magically work. Okay, that was also easy. Cluster is still working. In that mixed mode, you can read your data, and now we can try to replace the final node. Kibana will now stop working because Kibana is connected to that one node, and we can try to do basic curl commands against another node. Let's see how the cluster is doing. And you can see, okay, we have just these 2 nodes now. Elasticsearch 2 already has become master now. And the 3 node will come back, and is already back. And now we can reload Kibana, because, well, that kicked us out immediately. And hopefully Kibana is still there, and we can continue here. Awesome, that worked. So we have upgraded that. In the demo, it looks pretty easy, but it can be, yeah, challenging. Be careful with rolling upgrades. Next thing we've added in 6 is the Floodstage Watermark. Anybody remembers or knows what other watermarks we have? We have the low and the high watermark. So the low watermark basically says, like, if you hit that low watermark, we will not allocate a new shard on a node, because, like, watermarks are about disk space, like how much disk space is still available. If you have less than 85% or more than 85% of the disk space used, we will not allocate a new shard to that node. If you hit 90% disk space usage or more, we will actively try to migrate shards away from that node. And flood stage basically means is one node has hit 95% of disk space, and previously we would keep writing until we hit the limit, and then you might even corrupt the index. Now that new flood stage watermark is basically locking the index, you can still write it, but you cannot read any data from it. But it will lock any index that has a shard on a node that is affected by that flood stage watermark. And you will need to actively kind of release the lock for that index again once you have changed it. We could demo that, but it's kind of like a lot of locking and back and forth. Let's do something more fun. We have now added sequence numbers. Sequence numbers are kind of the magic source for more resiliency. So basically, we have an operations log for all the operations going in, and I can just demo that. So start playing. Oops, no, that's not what I want. Yes. You write some data to the primary shard. You replicate it to the 2 others. They have kind of like, that is the local sync. When you write out new data in the response back, they acknowledge that they have written back those 0 documents. And whenever you write something out, they acknowledge it back, and you have this sequence number. And then you know you have written everything out to the other nodes, and it has been acknowledged already. So now everything is moving up. They will move up as well. And now we are writing some more data out. And then suddenly, the primary node will die. So it has died. That has become the new primary node. And that is taking over. It never received the document 4, and will actually tell the other one then that it needs to throw away the document 4. And that is the new mechanism how they keep in sync. So they know, like, every operation that is per shard, every operation that is coming in has a sequence number, and it will be kind of replicated to the others. They will acknowledge back that they have written a specific version or number of a document, and only then you have a global checkpoint, and then it knows all the shards or all the nodes have written that. And if you have a failover, you can actually distinguish, like, which operations have been applied and which should be rolled back, and it can do that. And we can even demo that. Surprisingly, that's easy. So I'm creating a new index, one primary shard, one replica shard. They're going to the nodes 2 and 3. The index is called sequence numbers. Just to show you how it looks like, you have the primary shard on the Elasticsearch 2 node, and the replica shard is on the Elasticsearch 3 node. And now we're creating 10 new documents. And this already looks the same as it did before. The only thing that is new here is this one, the sequence number and the primary term. These are new and added by the sequence numbers. So basically, whenever you add a document, the sequence number will be counted up. The primary term stays the same. Once I hit 10 nodes, that's easy. By the way, every operation you do counts to the sequence number. So even if you insert a document, okay, it will be incremented, but if you delete something, it's also an operation, so that will also increment the sequence number. It's kind of just like an operations log, oplog in other databases. It's just like counting the sequences. Now note the primary term. Let me see which one had the primary shard, because I want to kill that node again. Oops. So the primary shard is on Elasticsearch 2, so we are stopping Elasticsearch 2 now again. Stop Elasticsearch 2, that's good. And now we can do read operation. Okay, it was the master node. So right now it's falling over in the background to find the new master node. See how that is going. Yeah, okay, that node died. I hope the others are coming back to life. In the meantime, we can already restart Elasticsearch 2, so it can rejoin the cluster as well. Right, so you can see Elasticsearch 3 took over as the primary shard. Elasticsearch 2 is not here yet. It will join the cluster any minute now. But we can already start inserting documents again. And now you see the primary term here has changed. So every time the primary shard changes, we kind of fall over. So you need both of these counters to know which operations have been applied and what is working correctly. So that has shifted. And you can see the sequence numbers should even out those again. So both of them have 12 now here. You could now kill more nodes, and the other big thing the sequence numbers give you, if a node is not available and misses out on some updates, in previous versions we did a file-based replication. So whenever we write out data to the disk on Elasticsearch, it's written out to Lucene segments. And the problem is that these Lucene segments, since they're written independently, the exact segment is often not the same, but we were doing file-based comparison, so even if a node was just dropping out of the cluster for 3 minutes, you might need to replicate gigabytes of data, just because some minor difference on the disk, and we would just copy over all the data. Now with that sequence number, we can actually replay the last operations that you missed out on. So recovery is much quicker on that. And you can even see like how many sequence numbers you have recovered based on that. Yeah, the final thing that is important I want to tell you is, who is using multiple types per index? Anybody using multiple types per index? Yes. That will go away. We have been saying that for a long time, don't use multiple types per index, but we're finally getting rid of them. But it's a long-term process. Because kind of multiple types per index were a lie all along, because Lucene doesn't know that concept. It was always kind of an artificial concept we put on top of it, and it was it's just a filter that we added. So there were multiple problems. One of them is if you have different types and you have the same field name in different types, they all need to be the same data type. Because Lucene doesn't know that, for them it's just always the same field. Different document types often increased the sparsity, so you have like varying documents, and then you would have like a lot of optional values or some values in one document and not the other. And that was not great storage-wise for Elasticsearch, or Lucene actually. And scoring, the quality when you find something, is also, it's not per type, but only per index. So that might be confusing, but you would then score over all the types, and that was often not what you expected. So we have a kind of elaborate plan to get rid of that. So in 5.6, you can opt into single types. In version 6, you can only create a new index with a single type. You can still use old indices if you upgrade it. With multiple types, you can still use those, but you cannot create a new index with multiple types. In 7, which will be in a year or so, the type in the API calls will be optional, because we expect that there will only be a single type per index, so we can't just throw out that parameter. And in 8, at last, there are no more types then. They're just gone. If you want to see kind of the in-depth roadmap, that's the URL. I'll put out the slides afterwards. But it will be a painful process, but we kind of try to spread it out a bit and make the upgrade path nicer. And I can actually show you that. That is the last thing I can show you. So I've just inserted these 3 documents, and you see I have the type 1, the type 2, and the type 3. And then I insert a document in a new index called notypes doc1. And that's been created. And if I then try to insert a document into that index with another type, like the first one was called doc, that is kind of the default we're using for everything. But if you use a new type called other, it will now throw you an exception, and it will tell you that that is no good. How do you migrate forward? Like, how do you get rid of types? Like, we have this reindex API where you actually can say, like, take the index types, I use that, and I want to store that into the index no types. And what I'm basically saying then is I'm changing the ID, because previously the ID needed to be unique per type. So the new ID includes the type and the ID of the original document. Plus, we're taking the underscore type field that we were storing and store it in a custom field type. And we just set that underscore type field to doc. So if I run that, it will replay my 3 documents in the new index. And then you will see, like, you have that is index is no types, type is doc, and then you have the ID 1. And this is the replayed document. So this is also type doc now, but it has the ID type 2, 1, and the original document type 3, 1. And that would be the way forward to migrate away from that. That is kind of one of the most important takeaways here. Yeah, and then we have something after 6.0 comes out, which will be hopefully later this year. We have minor improvements like adaptive replica selection. By now, we can either read data from the primary or the replica shard. And there is a very nice paper telling you how to more cleverly pick which shard to go to. And yeah, we're basically calculating which is the least busy shard, and we'll try to always query the least busy shard if we have the choices. It's giving you some performance improvements, like some of them, if you don't have a load and you just have one replica, it might get worse, but all the others are kind of getting faster. So this is another nice performance improvement that is kind of like on the algorithm side, hooked in. We're trying to improve there as well. It's off by default for now, but it will be only out in 6.1. Oh yeah, final thing, benchmarks. We're always doing benchmarks. Though we're not comparing to other systems. This is my favorite comic for benchmarks. Whenever you see somebody doing benchmarks against their competitor, this is pretty much what they're doing. So they're picking similar conditions, which are good for them and bad for their competitor, and then they're saying like, oh, we're so much faster. Don't do that. We don't believe in that. We do benchmark internally against our own products pretty aggressively, but not against others. Because we want to avoid this slow boiling frog problem. Anybody heard of slow boiling frogs? Yeah, so the slow boiling frog is basically you make a change, your thing gets, I don't know, 0.5% slower. And you make another change and it gets 1% slower. And one by one, you don't really see them. But you need like long-term benchmarks to actually see that overall, in which direction are you going? Are you getting worse or are you getting better? And we have a colleague he's written his own benchmarking tool, especially for Elasticsearch. And he's doing benchmarks full time. So he's writing them and he's poking people when he sees like, tonight something changed. And we're running them nightly on bare metal, always the same machines, nobody can touch anything, like no upgrades, nothing. So it's really comparable. But we're pretty hardcore into that benchmarking stuff as well now. Okay, to conclude, we've kind of seen a lot of stuff. So we've seen more strictness. We have played around a lot with the child allocation. We saw the cross-cluster search, which will be more intelligent to search across clusters. We've done a rolling upgrade, which luckily even worked. We've seen that Floodstage Watermark, don't corrupt your indexes. At some point, we'll just stop writing if your data is, or if you don't have enough disk space free. We have sequence numbers to make resiliency better, and it will even enable new features in the future like cross-data center replication. So while one cluster still needs to be in one data center, we might be able to replicate the data to another cluster somewhere else. Types are going away. And yeah, adaptive replica selection, that is kind of a future improvement. Let's see when we enable that for good. Yeah, if you want to play around with 6.0, you still have the chance. We have release candidate 1 out now. There will be at least one release candidate 2. If you test that, find a new bug and report it, we will send you some special swag. I'm not sure what it is, but there is some special swag you will get. But I'm not handling the swag, so I don't know. But we have this Pioneer program, so we're actively looking for people to test our betas and release candidates. And you will get a mention in the release log and everything.